Okay, so hello everyone. So our today's topic is actually root and radical. Okay, so our today's topic will be root and radical. So this one is actually a really important topic. Okay, sorry for the writing. Really important topic. Okay, it is a really important really important topic. So we're going to talking about some of the really important information first. Okay, we having some definition, and we also having some and some property to actually talking about. Okay, so since there are so many things we have to talking about, I will try to just try to keep in mind. Okay, try to keep in mind. So our first definition over here is the definition of the square root. Okay, the definition of the square root. So let me actually zoom in a little bit. Okay. Okay. Also, the definition of square root say we having this notation. Okay, as the square root is the principal square root, right? Is the principal square root of a. Okay, it is the non-negative number whose square is a. Okay, so basically so try to remember this notation. So this is this is kind of like the basic of how a square root look like. Okay, so this is actually a square root. Okay, a square root. And so how you read it, you basically read as this part. Okay, the square root of a. Okay, the square root of a. So and after that he say it is the non-negative number whose square is a. Okay, so suppose our negative number over here is x. Okay, so what that means is that the square root x square is equal to a. So it's basically is that kind of meaning. Okay, so let me actually using an example down below to actually show you guys how it look like. Okay, so everyone knows that, right? Everyone knows that the everyone knows that the 49 is actually equal to 7 square, right? So I think now this part makes sense, right? So I think now this part makes sense, right? Because the definition is saying about that it is the non-negative number whose square is a, right? So our a over here, a is equal to 49, right? And you can see 7. So right, so it is the non-negative number. So this 7 square is actually a non-negative number, and it is equal to 49. Okay, so that's basically another way how you actually solving for a square root. Okay, so basically so over here we are assuming if nothing is written, over here you are assuming that this is a square. Okay, that's why it is say a square root, because 2 is actually a square, right? So if nothing is over there, what I mean is that if you see is there's nothing over here, so you assume it is actually equal to 2. Okay, a little more detail is that the 7 is 49 over here is actually 7 square, right? So you see a square, you see a square root over here, and then you see a square over here. So those things get cancelled. It's just basically equal to 7. Okay. Okay. So let's move into the next definition over here. Okay. So the next definition is, I think, is basically what I say it. Okay. The definition of the pair of the radical expression. Okay. Here is more a general one. It's more a general matter. Let me read it. The principle of the nth root is written as this. Okay, so let me zoom in a little bit. Okay, as I tell you guys before, if let me actually use an example. If there's nothing over here, you assume it's 2. Okay, but if there's something over here, suppose we having something like 3, or we have something like 4, the square, because if we have something like that, okay, then you okay, so basically what I want to say over here is that let me actually clean it. Okay, so I say over here, if there's no number over here, then you assume it's actually equal to 2. And if you have something like that, okay, then it is what it is. Okay, it is what it is. Okay, so over here we have an example over here. Okay, so let me actually talking a little bit more detail about this. Okay, so as you can see, let's actually talking about in the 2 way. Okay, one way everyone know that 64 is actually equal to 4 to the power 3, right? I mean, 64 is equal to 4 to the power 3, right? So that's one of the part. So I mean, the definition upward saying it is, so over here, right? Over here, okay, over here, this definition say it is the non-negative number whose square. Over here is not square, it is actually 3, right? Okay, so it is actually equal. Is it actually equal to 3? Okay, so let me think. It is actually a cube. Okay, yeah. So all I want to say over here is that if you want to actually solving, so all the point over here is that if you actually want to solving for a cubic root. So okay, so over here we having a cubic root. Okay, we having a cubic. Let me actually write it down. Okay, a cubic root. Okay, so basically, whatever you want to solving, whatever you want to actually solving, anything over here we are actually solving a cubic root. So you want to make sure you having something to the cubic, the power. Okay, so that's how you basically solve it. So so all the point which I want to tell you guys right now is that how you actually solving equations, how you actually solving for a nth root. Okay, so the principle over here, what we have is an nth root. So if you actually want to solving any, for example, if you want to solving a cubic root, that's our example over here. Then you want to making something to the power of cubic, to the power of 3. Okay, so that's basically how you actually solving for a cubic root, and for any nth root. Okay, so one way, so another way to actually show this problem is basically so here we have here a cubic root, and the inside is 64 is actually equal to, so 64 is 4 to the power 3. As you can see, we having a cubic root, and then we having a power, the power to 3, right? So those things will cancel, and then it add up with number 4. Okay. So after that we are actually going to talking about the perfect square integer. Okay, the perfect square integer. So the example for some the perfect square. What do we mean a perfect square? Is that we having 1 square equal to 1, and then 2 square is equal to 4, and then 3 square is equal to 9, and then let me give you the last example. Okay, a perfect square. Okay, as you can see, everything over here is square, and it is those integer. Okay, so the perfect square integer represent 1 and then 4 and then 9 and then 16. Okay. So so one more thing I want to talk about is that those will be useful. So for those will be useful for us to actually finding the square root. Okay, suppose we having a root 1. Okay, so if nothing is greater, then you assume it's 2. Okay, so you can see it will be 1 because 1 is 1 square, right? It will be the same, right? So let me give you one more example. Okay, we have 4 is actually equal to 2 to the power 2. As you can see, is equal to 2, right? So those perfect square integer is actually we can actually find the square root of the perfect square integer really easy, right? Okay, that's why I say it's quite important. Okay. Now the last thing we actually going to talking about, this is the last thing, is the irrational number. Okay, the irrational number is a number that cannot be written as the ratio of the two integers. Okay, it cannot be written as the ratio of the two integers. So let's talking about let me actually give you one example. Okay, so as you can see, if we have a number 2, it can be written as 2 over 1, right? So basically this is actually a ratio of two integers. So that means that the real number 2 can be written as a ratio of 2, a ratio. Okay, so the ratio that means something over something, ratio. Okay, so therefore this actually a rational number. Okay, this one is actually a rational number. Okay, so let's talk about the next thing. So one of the really important fact you need to know that is that for the irrational number, okay, so the irrational number, their decimal places. Okay, their decimal places are always non-terminated and non-repeating. Okay, so let me actually write it down some words. Okay, non-terminating means never stop. Okay, it's never stop. Non-terminated, so that means it's never stop. The decimal place is just going getting continued, and then non-repeated. Okay, so non-repeated means something like 1 3 1 3 6, the decimal place. Okay, the decimal place is something like 1 2 3 7 7 5 3, and then maybe 1, maybe 5, something like that. Okay, so this is what we call a non-repeating. It is non-repeating. Okay, if you so everyone know if it is repeating, then it's something like maybe longer, like 1 2 1 2 1 2 1 2, something like that. Okay, if it is repeating, then it's something like that. Okay, so it is a two really important features to identify the any irrational number. Okay, if one is non-terminating, it means it never stop. The decimal place keep continuing, and so that means those two statements have to be valid all the time. Okay, and non-repeating means it just the number is always different. Okay, so so one of the example of the rational number is root 2. Okay, you can using a calculator to actually find the number for the number of the number of the square root 2. Okay, you can using a calculator. So as you can see, the root 2 is actually equal to this, right? And you can see this number is actually non-repeating, right? It's actually non-repeating, right? Actually move it down a little bit. Okay. So first, this number is actually non-repeating, right? So based on the number, you can see it's not repeating because we have So now you're focusing on the decimal place. Okay, so you have 41, 42, 135. It's not repeating, right? And as you can see, we having something over here. It's going to continue. So that means this one is also non-terminating. Okay, so you know this actually. So this one is actually an irrational number. Okay, so this one is actually a irrational number. Okay. Okay, this one is actually an irrational number. So, okay, so keep in mind with those identities. Okay, with you know, first thing is a rational number. It just cannot be written as a ratio of the two integers. Okay, the second thing is the most important. The second important fact is that the decimal place. Okay, the decimal representation. The decimal is always non-repeating and then non-terminating. Okay. Okay, so now let's actually doing some questioning. Okay, so now let's basically doing some questioning. So I will tell you guys how to add. So first of all, let me actually show you all the questions first. Okay, so this section, how many questions what we have? Okay, I got totally 8 questions. Cause this section is kind of like a little bit long. Okay, so let me. Okay, yeah. So we have totally 8 questions. So now is the time for you to actually skip any question. You know, if you think it's easy for you to actually do it. Okay. Otherwise, I will basically will explain all the questions in detail. Okay, I will explain all the questions in detail, and you know, give you some idea about how you actually solving those problems. Okay. So let's straight to okay. So let's straight to the question 1. So you know so basically all the information I talking above will be applied over here. Okay, will be applied over here. If you kind of like, you know, not really not sure about it, then maybe listen, you know, maybe try to you know, go back, you know, okay, go back and then listen about those concepts again. Okay, yeah. So let's start with question 1. Okay, so question 1, let me actually zoom in a little bit. So as you can see, we having something in a square root, right? In a square root, right? So if nothing is over here, we assume it's actually equal to 2. Okay, so okay, so basically over here, you basically over here, so basically over here, you know that 25 is actually equal to 5 squared. Right, so you know that the 25 is actually equal to 5 squared, and 256 is actually equal to 16 squared. Right, 200, you know, the number over here, 256 is actually equal to 16 squared. Okay, so after that we can actually write this into something like this. Okay, so we pull out the square root. Right, so now I think. So now you can see it, right? So as I say it before, you know, you want to solving for a square root, you need to have something to the power 2. You need to have something to the power 2, and we have something else to the power 2. So those things get cancelled. It just basically become 16 over 5. Okay, so that's our solution for this problem. Okay, so always remember, like, you know, x squared is equal to a. Okay, always remember x squared is equal to a. So you know, you know, like we have something like a as 9, so we need to have 3 squared, right? So we need to have 3 squared. So that's how we actually solve. Okay, remember this. Okay, this is like kind of like a hint. Okay, so now let's move into the next question. Okay, question 2. As you can see, we having a cubic root. We having a cubic root, right? So as I tell you guys, if you actually want to find a square root, you need to have something to the power 3, right? You need to have something power to the 3. So over here, you write it down, and then you write negative, and then you have 8. 8 is actually 2 to the power 3, right? And then 27 is actually 3 to the power 3, right? Okay, so now you continue. So now what you have is we have negative 2 over 3 to the power 3, right? Okay, so what we have over here is a negative 2 over 3. So you basically putting out those power outside. Okay, so now you can see, we having a cubic root, and we have something to the power 3, right? So those things get cancelled. Okay, those things can get cancelled, and our final solution is negative 2 over 3. Okay. Yeah, so you may confuse a little bit. So as you can see, the cubic root over the cubic root, this is a cubic root, right? So it is power. It is a cubic root. So that means right. So that means the solution can be negative. Okay, because we having a cubic root, so the solution can be positive or negative. Okay, so let's move into the next type of question. So the next type of question is you want to state whether the root is rational or irrational. Okay, so basically as you can see, so as you can see over here, we having a cubic root. And then 9 is actually equal to 3 to the power 2, right? As you can see, we only having a square root over here, but outside is actually outside is a cubic root, and then we only having a power 2 over here. So that basically means we cannot solving this problem. Okay, we cannot actually solve it, right? We just basically cannot solve it. Okay, and so the next thing what you have to do is to try to using your calculator to actually find the value for the cubic root of 9. Okay, so how you read this is the cubic root of 9. Okay, that's basically how you read it. And I find the number is 2.080083823. So as you can see, as we talking about before, irrational number tend to have non-repeating decimal and non-terminating, right? So as you can see, the number over here is actually non-repeating, right? Non-repeating, and this is going to continue. It will never end, so it's going to be non-terminating. Okay, you can see this number is non-repeating, and then it's going to continue, so it's non-terminating. So that means this is actually an irrational number. Okay, irrational number. Okay, so this is actually irrational number. So okay, so let's move into the next one. Okay, so the next one, what we have over here is we having a cubic root, and then we have negative 27 as the number. So as you guys know, negative 27 is actually equal to negative 3 to the power 3, right? Okay, yeah. So now you can see that we having a cubic root, and then we have something to the power 3. So those things get cancelled out, and our final solution will be negative 3, right? So it will be negative 3. As you can see, negative 3 is actually a real number. So that means it is going to be a rational number. Okay, -3 can be written as -3 over 1. Okay, so -3 can be written as so one of the condition for the rational number is you need to have a rational number. You need to have rational number, right? So let me actually write it down. Rational number. One of the condition is that you need to have a ratio of number, right? A ratio of number. Okay. Yeah. Okay, that's one of the things we're talking about in the. That's one of the definition we're talking about, at the beginning. Okay, so rational number, you need to have a ratio of number, right? So as you can see, number over here is -3. -3 can be written as -3 over 1. So that's a ratio. So that's, for question 4, it is a rational number. Okay. Okay, so let's move into the next kind of question. Okay, so the next kind of question is saying, determine whether each statement is true or false. Each statement. Okay. So let's take a look about question 5. Okay, question 5, we're having something like this, and then nothing is written over here, so we assume it's actually equal to 2. Okay, it's a real number. Okay, so that's the statement. So this square root, the integer, something is a real number. So now let's actually try to solve it by ourselves. Okay, so you can see we having a square root, right? So let me do it step by step. Okay, we have 4. 16 is equal to 4 squared, right? And then we have so basically the right thing over here is you first have to simplify this part a little bit. Okay, yeah. So one second, we have in y. So first you have to simplify this part a little bit. So we have 16. As you guys know, we have x to the power -4 and y to the power -4. So this basically become 1 over x to the power 4, y to the power 4, right? Okay. So what we have right now, okay, so you simplify a little bit, x to the power -4 will be x to the power -4, y to the power -4 will become 1 over x to the power 4, y to the power 4, right? So after that, what you're gonna do is you write it down. Okay, you write it down, and basically over here, 16 is actually equal to 4 to the power 2, right? And then x to the power 2, y to the power 2 to the power 2, right? So what you basically want to do over here is you want to making something with power 2, right? So that's how you actually cancel the square root, right? So you want to make something to the power 2, right? Okay. So that's basically how you if you have something to the power 2, then you can actually cancel the square root, right? So as we moving further, you end up something like this. Okay, you end up something like this. Yeah. So let me take a look for. Yeah, you finally end up something like this. Okay. So as you can see, now we having square root. We having a square root, and we have a power 2. So those get cancelled. So we finish to simplify. Our final solution is 4 over x squared y squared, right? So over here the statement say this is gonna be a real number, right? So this is gonna be a real number, right? So as you can see, x squared, and then we having a y squared. Since basically you know that if x squared and then y squared, so that means the statement down below have to be bigger and then equal to 0. That's what you know, right? So because both of them are square root x to the power 2, so you know they have to be bigger than 0, right? They have to be bigger and equal to 0, right? So this is actually a real number. So the statement over here is actually true. It's actually, yes, true. Okay, the statement over here is actually true. Okay, so the statement is over here is actually true. It is a real number. Okay, because you can see this statement is actually also writing in a ratio, right? A ratio, right? Another way you can say is, you can see, because this is a real number, because it can be written as a ratio. So one of the thing I want to include over here, let me write it down over here. Okay, let me actually write it down over here. So we have all the number as the real number. Okay, every number will be included into a real number, and then in real number we have two separate pairs. Okay, while we having a rational number, that will be a part of the real number. Okay, and then we having an irrational number. Okay, irrational number, that will be also another path. Okay, so that's basically, so if a number is actually a rational number, it's going to be a real number. Okay, so if a number is actually a rational, so basically over here is actually, okay, so it's not like that, I guess. So over here, the statement is a real number. Okay, so okay, so the answer for here is actually true. Okay, that's all you have to know. Okay, so do not get confused over here. Okay, so basically this statement is true. All right. So let's moving down below. Okay, so let's actually moving down below. Let's look at this statement. So here, what over here the statement is saying this is actually equal to this. Okay, the statement over here is that saying this is actually equal to this. Okay, so let's simplify it. So we're gonna simplify from here. Okay, so let me actually write it down first. Okay, so let's actually doing a little bit more simplification, because over here we can actually write it the denominator as x plus 5 and then x minus 5, right? Okay, so as you on this step over here, as you can see, we are on this step over here and we cannot do anything, right? So the square root over here is 2, right? On the denominator, okay, on the denominator, on the numerator, what you can see over here is that we having a square root and we have nothing to the power 2 inside, right? We have nothing to the power 2 inside, so you cannot cancel anything. So you basically, you already finished this question. I mean, you already solved this problem into the synchronous form, right? And the statement over here is equal to this, right? So it's actually not equal, right? It's actually not equal to the square root of x plus y. So, right? So okay, so right, so the for the thing over here, this already the simplest form. We cannot cancel anything more than that, and you can see those two statements are actually totally different, right? So the statement over here is actually a false statement. Okay, so right, so as you can see, the right hand side, the right hand side and the left hand side, those two statements are totally different, so it cannot be equal. So therefore the statement is false. Okay, So now let's actually moving to the last kind of question. Okay, the last kind of question. So here the last two questions over here is we want to actually zoom me a little bit. Okay, you want to find two expressions that are equivalent. Okay, two expressions which is equivalent. So the method which you are going to use it over here is we trying to solve all of those one by one. Okay, so let's do the first one first. The first one we having a negative. As everyone knows, 25 is actually equal to 5 squared, right? So you know that. I think up on this point, you guys should understand how you actually solving for rational equation. Okay, so for the square root. Okay, for the square root. So over here you can just basically write down the final solution is negative 5. Okay, and you're looking at the second one. The second one, we don't need to do anything because it's already in the simplest form, which is negative 5. Okay, and you're looking at the third one, you can see over here we having something negative. We having a square root, right? We having a square root, but the number inside is actually a negative number, right? It's actually a negative number. Okay, so what I mean by that is you cannot have something like this, right? We having a square root, right? We having a square root, but the number over here is actually a negative number, right? So as everyone know, if we having a square root, then the number have to be positive, have to be bigger and equal to 0, right? If we having something, if we have something x squared, if we have x to the power 2, we need to have the number we need to have x, we need to have some number which is bigger and equal to 0, right? But the number over here is negative 25. So our final solution over here is non-defined. Right? It is actually non-defined up on this point. Okay, so after you so as you can see, negative for the first statement and the second statement both are negative 5. Both are negative 5. So you know those are the two statements which is equivalent to each other. Okay, those are the two statements which is equivalent to each other. Okay, so now we finish this problem statement. Okay, so let's move into question 8. Okay, question 8, I think this one is actually the last question. Try to doing this question by yourself. Okay, try to do this question by yourself. Pause the video. Okay, now let's do the question together. Okay, as I say it before, we have to, in order to make sure everything is right, so you have to solving each of them one by one. Okay, so let's do the first one. The first one over here, we having the fifth root, right? We having the fifth root, right? The fifth root. So the inside will be negative 2 to the power 5. Okay, so 32. So let me actually write it down. 32 is actually 2 to the power 5. Okay, 2 to the power 5. 32 is actually 2 to the power 5. Yeah. So over here we having something negative. We have negative 32. So it's going to be negative 2 to the power 5. Okay, 5 and 5 get cancelled. Our final solution will be negative 2. Okay, and then let's do the next one. The second statement. The second statement, as everyone know it, we having the fifth root, and then 32 is actually equal to 2 over 5. 5 and 5 get cancelled. It will become negative 2, right? And the last statement is we having an absolute value of negative 2. The absolute value of a negative number the absolute value for any number will be a positive, right? So our final solution will be the positive 2, right? So as you can see, negative 2, negative 2. So the first two statement will be is the 2 which is equivalence 1, right? So those two which I circled it is the equivalence 1. Okay. Equivalence. Let me actually write it down. Okay, those two are the equivalence 1. Okay. So hopefully you just get the right answer. Same as me. Okay. Yeah, same as me. So the topic. So in this topic, we basically cover a lot of definition, right? So we basically cover a lot of definition. Okay, we have been covered the definition of the square root and how we actually solving it, right? We covered the definition of the square root, okay, and then we also covered the definition of the radical expression, a more general one, right? A more general one, okay. And we also been covered the perfect square root, okay, the perfect square root, the perfect square integer, okay. And then finally we have been covered how the definition of the irrational number, right? How you actually know that is an irrational number by using those conditions, right? Okay. So right now, make sure you actually subscribe to my channel, okay? Yeah, so make sure you actually does subscribe to my channel, okay? So if you still having any question, please leave a comment below, okay? So if you still having any question, please make sure you leave a comment below. I will try to answer your question as long as I see your comments, okay? As long as I see your comments, yeah. So also also remember, turn the notify button on, okay? Turn the notify button on. I will keep uploading videos, okay? I will keep uploading videos, yeah. So hopefully you guys does learn something from this video, okay? Hopefully that you guys does learn something from this video, okay? Yeah. So see you guys on the next video.